Hello, good day. This is our new topic, which is a mechanical system of the building, and we are focusing on the components of the air conditioning. Okay, before we will start our discussion, we must know our learning outcome. In this lecture, you will now identify the appropriate mechanical fixture with its properties and installation fabrication methods. Now, before we proceed, let's have a short summary or short review about air conditioners. Air conditioner is requires some input of work to operate, otherwise entropy would decrease naturally, which is forbidden by the second law of thermodynamics. And in the common definition, it's a system that is used to cool down a space by removing heat from the space and moving it to some outside area. So the cool air can then be moved throughout the building through ventilation. Now, this is how the air condition process. So from the outside, the inside, till the fan, evaporator, to compressor, to condenser. The air conditioner is a key component of the HVAC system, which focuses on home temperature control in order to maximize comfort and livability in a space. Air conditioners are called split systems because there is an outdoor unit, which is the condenser, and an indoor unit, the evaporator. These two systems work together to accomplish the task of cooling an interior space while also dehumidifying it. The dehumidification happens as warm air from inside passes over the cold evaporator, where the warm air condenses and loses moisture, just like warm air does on a cold glass of lemonade. So that is just a simple scenario. The split system describes an air conditioner with separate indoor and outdoor components. There is also another type of air conditioner which combines these components into one outdoor system, which is known as a package system. I already attached this package system on the previous week. Okay, this is the first component, evaporator. An evaporator is a device used in process to turn the liquid form of a chemical substance, such as water, into its gaseous form, vapor. So the liquid is evaporated or vaporized into a gas form of the targeted substance in that process. So evaporator is an important component together with other major components in a refrigeration system, such as compressor, condenser, and expansion device. The reason for refrigeration is to remove heat from air, water, or other substance. So we must get to know the evaporator coil. Okay, this is the picture of the evaporator coil. So an air conditioner's evaporator coil, also called the evaporator's core, is the part of the system where the refrigerant absorbs heat. That is, it's where the cold comes from. So air conditioners don't actually produce cold air in the way a furnace produces heat. Okay, that is, remember it. Instead, they use refrigerant or coolant to absorb heat from the air, carry that heat outdoors, and release it into the air outdoors. The refrigerant circulates continuously to remove more and more heat from your home until your indoor air temperature reaches the one you've chosen on the thermostat. Okay? Evaporator and condenser coils handle different sides of the cooling cycle. Okay, let's walk through the evaporator coil first. So the evaporator coil is located inside or near the air handler where the blower fan is. Now, this is the typical auto air conditioning system, how it works. So as you can see, we have the evaporator producing the cold air. Now we are the condenser, which is located outside. So first one, compressor, passing to the condenser. then the receiver or dryer, then expansion bulb, then evaporator, and it is cycle. So as the air conditioner runs, the compressor rather pulls cold, low pressure liquid refrigerant through the tubing in the evaporator coil. So the refrigerant passes through the expansion bulb here. So this valve relieves pressure from the liquid refrigerant, which rapidly cools it. So the liquid refrigerant leaving the expansion valve is quite cold, which what it allows to absorb heat from the air. So the expansion valve also controls exactly how much refrigerant flows to the evaporator. So more advanced expansion valves such as thermostatic expansion valves, just like TXVs, can manually control the flow to improve the system overall energy efficiency. So as the refrigerant flows, the blower fan draws hot room air over the evaporator coil here. So the refrigerant absorbs heat from the passing air, and it at this does so. So it warms up and evaporates. So when the water vapor in your warm house of the air hits the cold evaporator coils, the water vapor condenses into liquid form and drips down into the condensate pan, which drains the water away outdoors. This is how your evaporator coil reduces the humidity in your home. So makita niyo na magtulo siya sa likod sa inyong bintana. How to care the evaporator coil? So we have 4. Impaired heat absorption and cooling capacity. Because of the way they operate, evaporator and condenser coils both need to be kept clean to perform as intended and reach optimal energy efficiency. A dirty evaporator coil can experience a number of problems. So, 2. Higher energy use. Even a fine layer of dust on the evaporator coil reduces its efficiency. The duct acts as an insulator, keeping the heat in and air away from the cold coils. That means the coil can absorb as much heat as it can when clean. So your system will then have to run longer to provide the indoor temperature you want, which means it will use more energy because it isn't absorbing enough heat. The refrigerant running through a dirty evaporator coil doesn't warm up as much as it should. So this very cold refrigerant causes water vapor in your air to freeze rather than condense into liquid. So eventually the whole evaporator oil can frost over. So frost and ice build up. So how the condenser coil does its job? So we are done with the evaporator coil. We can proceed now to the condenser coil. So what is an air conditioner condenser? So your air conditioner condenser is contained in the large square unit outside your house. Okay. So although this is the outer unit, the whole unit is called the condenser unit and contains multiple components. Evaporator and condenser coils work together to cool your home. So the evaporator coil wouldn't be much good without a condenser coil to complete the second half of the cooling cycle. So as you can see on the figure, this gas leaves the compressor and flows into the condenser coils. This is where the refrigerant releases much of the heat that was absorbed from your home. The fan on the top of the outer unit blows air over the condenser coils. So the refrigerant inside loses heat. The condenser many coils increases the amount of the time the refrigerant is in the path of flowing air, giving it the plenty of time to release the heat that was carried out of your home. As it cools, the refrigerant changes from hot gas to a hot liquid. From there, it flows back through a copper tube into your home into the expansion valve located in the indoor unit near the evaporator coil. So this is the process. So keeping the condenser in shape. So check the condenser periodically, and if you notice debris build up, shut off power to your whole system and use a stiff brush to gently clean the fins. Okay, it's the fins. On occasion, an air conditioner condenser can develop frost or even a complete casing of ice. Assuming that the condenser unit itself is clean, ice ups like this usually mean there's an airflow problem elsewhere in your system. This could be a dirty air filter, dirty air registers, and vents, a duct blockage of a dirty evaporator coil. So ice on the condenser can also be caused by low refrigerant, which requires a call to a technician. So when the cooling season ends, protect the outdoor condenser from the elements by covering the top with a piece of wood held down at all four corners by bricks. So this keeps snow or any materials from piling up inside. So I think we are done with the evaporator and condenser. We can now proceed to the 5 important things to know about our air conditioner compressor. First of all is the compressor location, compressor function. Okay, I think there's a typo error. Compressor repair. Okay, the compressor is one of the most important parts of your air conditioning unit. Not only does compressor play an important role in the cooling process, but it also ensures that the unit works effectively and continually. So to understand how your air conditioner compressor works, you should know about its location, function, it is compressor maintenance, and compressor needs. Once you do, you'll understand the connection between your air conditioner's compressor and regular HVAC system maintenance. First one, the compressor location. Remember that the outer unit connects to the indoor part of your air conditioning system through a copper refrigerant tube. So once connected, these two parts work together to absorb hot air from inside your home and transform it into the cold air. Next one is the compressor function. So I will ask a question. How does the compressor fit into the picture? The compressor is responsible for moving the refrigerant between the evaporator and condenser coils, ensuring that the refrigerant changes to gas or liquid as needed. You can think of the compressor as the heart of the air conditioning system, and the refrigerant as the blood. So to this end, the compressor pumps the refrigerant through the system to keep it alive and running properly. Next is the compressor maintenance. So maintaining the compressor is crucial for the overall functioning of the air conditioning unit. So however, don't attempt to maintain this part yourself. So during a service appointment, your HVAC technician is responsible for everything about this. Compressor malfunction. We have the 3 noises coming from the unit. Okay? You may hear banging or clanking noises if a loose part is inside the compressor. The compressor has many moving parts, and it is easily susceptible to breaks. So if the compressor malfunctions for any reason, the result could be noises coming from the unit, insufficient cooling, or hard starts. So other consequence of malfunctioning compressor includes the outer unit running hot, the compressor burning out, and the air conditioning system not working at all. If you think you have a problem with your compressor, contact an HVAC maintenance or expert or any services professional for help. So compressor repair. However, if the compressor is to blame, replacement may be your only option. Depending on the problem's severity and the system's age, you may need to replace your HVAC system entirely. Now we have the air conditioner controllers. So we have one, control of on and off compressor. So the compressor is the most important component of vapor compression refrigeration system. So the on-off type of compressor used to be popular in the past, but DC inverter type of compressor is the latest technology in the market though more costly. Next is the control of AC-DC inverter compressor. The DC inverter or AC inverter type of control, which is obviously the compressor, it also be a DC or AC inverter type, has better control in that it does not have to turn off totally. So the third is the mode setting. The mode setting button at the remote control usually enables you to set the mode of operation. It can be set to cool mode, heat mode, dry mode, auto mode, or fan mode. So look at the manual provided to see the symbol of each mode. Labaw na nagagamit ka remote. Number 4 is economical mode. Most air conditioners controllers have the built-in economy or sleep mode function. So this function is used when one is going to sleep. When activated using the remote control, the air conditioner unit will raise the set temperature in steps after a period of time. So this is because the required cooling will reduce with one sleeps. The fifth one is the fan speed. Usually the fan speed can be changed into the low, medium, high, or auto. The auto mode has a built-in intelligence that determines the speed of the fan, depending on the room temperature and set temperature. Higher speed is used if the difference between these two temperatures is higher, and lower if low. Next is timer. Most units will also have timers that you can use to on or off the unit based on the clock of the remote control. The auto random restart is a feature that will retain the settings of the controls in the event of a power failure. Next is the ionizer. It is now a basic feature in most air conditioning unit. So it is located at the how can we say that? It is located at the inter unit and has a high voltage electronic module that ionizes the surrounding air with negative ions. And the last part is the air louver function. Helps to direct the airflow in the direction of the down control of the air. Most controls have at least up and down control the airflow in the direction of your choices. Some units may have left and right louver control as. Next one is we have the what are air cleaning devices. Air cleaners for particulates, suspensions of the fine solid, liquid particulates in air such as dust, fog, mist, smoke, or sprays include the fabric collectors. The first one is these filtration devices capture particulate contaminants as they pass through a special fabric filter. So as you can see in the pictures, we have 4. So fabric collectors, centrifugal collectors, electrostatic precipitators, and the wet scrubbers collectors. So the fabric collectors is the most common example of filtration device. It is such a bug house. Centrifugal collectors is the most common type. It is the cyclone collector, as you can see in the picture. These collectors separate particulates from the air by forcing the air to spin, similar to a cyclone or tornado. The third one is the electrostatic precipitators. Remove fine particles from the air by placing an electric charge on the particles. So the particles are then attracted to an oppositely charged collection plate. While the wet scrubbers collectors or scrubbers are available in many different designs, and they are also used with gases and vapors. Wet collectors use water to help force dust, gas, or vapor contaminants from the air. So we are done with the basic components of the air conditioning system, and we can now proceed how do we design your air conditioning system. Designing an air conditioning system might not seem like a lot of work, but it's actually a very complex process. That's because every building is different. Even when we know straight away what type of system you need, we still have to work out the most efficient, cost-effective, and attractive setup for you. So we hope that I will give you an insight into the steps we take to design a high-quality, bespoke air conditioning system. As you can see at the background, this is our indoor unit, and this hidden lines blue is the path of your air conditioning system. These are the key points of the air conditioning design process. Number one is to carry out the detailed site survey. Calculate the required heating and cooling load. Third is the identify a range of suitable units. Discuss the options with our customers and make recommendations. Fifth is select the most appropriate units. Next is to identify the optimum positions for the units, and last is the draw up for a quote for the installation. So this is the most important part, the draw up quotation. Sizing the air conditioning system. The required heating and or cooling load is largely determined by the area of the space. So as a rule of thumb, we will generally base our calculations on 120 watts per square meter. Because ceiling heights don't vary a great deal in commercial properties, the floor area is normally an appropriate measurement to accurate size each system. However, in some cases, particularly in high-ceiling buildings like churches or concert halls, it's necessary to work out the volume of the space. As well as measuring the area, we take into the account everything else that can affect the heating and cooling load. So we have to consider heat transfer through walls, doors, and roofs, existing heating and lighting systems, IT equipment, and occupancy levels. So the size orientation of the window is especially important. So after carrying out a detailed site survey, we have enough information to work out the required heating and cooling capacity. Once we've done that, we can start to identify the most suitable system for the space. Now we have different types of air conditioning system. So depending on the capacity you need, there are several types of air conditioning system to choose from, as well as the number of manufacturers. So the cheapest system is a wall-mounted single split, which is commonly installed here in the Philippines, which is typically used in server rooms, IT facilities, and small offices. In some old office, they are using wall-mounted split systems to heat and cool the offices throughout the year. But remember that there are more expensive systems such as VRF or VRV, and especially the ducted systems, and they are made up of several indoors and outdoor units. The indoor units are installed above the ceiling, leaving only the grills visible. So they are common in large commercial facilities, and they are applicable to the hospitals, hotels, and office buildings. Now, this is also the additional air conditioning design consideration. So when we design systems for our customers, we always take them through the different options. While the final decision is up to them, we use our knowledge and experience to give informed recommendations. So as an architect, as an engineer, we are paid based on our experience and recommendations. Business and residential customers often try to find a system that matches their interior and exterior design. So we can achieve this by choosing the most attractive units and keeping the system as discreet as possible. So getting down to details, customers may also ask for specific control functions and different styles of grill, as well as additional features like self-cleaning filters. So some optional extras can also be added at a later stage. Now, we need to consider also the positioning the indoor and outdoor units. Once we've selected the units and components, we also have to take the structure of the property into account. In every building, there are places where units can and cannot be fitted, whether that is due to electric wiring, plumbing, or the materials used in the walls. The outdoor units also need to be positioned carefully. All air conditioning units needs a certain amount of space to operate properly and should be kept clearly of dirt and debris. So it's sometimes necessary to fit cages around them to prevent damage and theft. Now, after considering some factors, the last part is design the route between the units. Okay? So the route between the units also affects the installation time. So if the layout or structure is problematic, even a short route might take longer to put in place. For example, if we occupy one room of a multi-story office building and need an outdoor unit on the roof like this, and we need an outdoor unit roof, we need to plan very thoroughly in order to make the installation feasible. So if the initial site survey is not done properly, the time and cost of the project could escalate dramatically. So this has negative implications for both the installer and customer. And it is one reason we take air conditioning design very seriously.